Hi, I'm Amir Hossein Mirzabozorg, and in this video I want to talk about comprehensive Abacus package. How to ask your video related questions. Don't hesitate to ask any questions you might have about the explanations presented in this video using the comments below. We try to answer all questions regarding the video details in the comments below. New Abacus users who want to develop their modeling skills faster in their projects can request user-oriented online and offline services. Subsequently, we offer step-by-step guidance, tutoring, and consultancy regarding their problems. The online service includes online sessions, and the offline service includes creating special tutorials. In addition, a combination of the two can be requested. This is the table of content of the comprehensive Abacus package. The comprehensive Abacus package consists of 16 chapters. The package suits engineers from different backgrounds, including mechanical, aerospace, civil, metallurgy, and textile engineering. Studying this package doesn't need any prerequisites. Also, you can purchase each of its chapters individually. Even you can ask for a customized package corresponding to your project or thesis. The comprehensive Abacus package allows beginners and intermediate users to become general FE analysts and prepare for related occupations. Chapter 1 is Introduction to the Finite Element Method. In this chapter, I have talked about first and second order elements and their differences. Also, I have talked about shape functions or interpolation functions and some practical notes about conducting FE simulations. In this picture, you can see a linear tetrahedral element, and here we have its local coordinate system, and here we have this element in Abacus. The purple numbers are the global node numbers, and the orange number is the element number. Chapter 2 is about system of units in Abacus. In this chapter, I will talk about SI meter and SI millimeter system of units, and also I will talk about how to drive your own system of units which suits your problem. And I will drive the units of the mechanical and thermal parameters. Chapter 3 is about modeling a beam fixed at both ends using beam elements. Here you can see the beam fixed at both ends, and at the center we apply a vertical concentrated force, and here you can see its profile. I will do the simulation using Abacus, and finally I will compare it with the analytical calculations. Chapter 4 is about modeling a beam fixed at both ends using solid elements. In the previous chapter, I did the simulation using beam elements, and in this chapter, I will do it using solid elements. And in this chapter, I will create 4 models. In model 1, NLGEM is set to off, and I will define equivalent pressure instead of defining concentrated force. In model 2, NLGEM is set to on, and I will define equivalent pressure again. In model 3, the NLGEM is set to off, and I will define coupling constraint for applying concentrated force to the solid elements. And in model 4, I will set the NLGEM to on, and I will define coupling constraint again. And finally, I will compare the results of 4 models. Chapter 5 is about meshing and partitioning. In this chapter, I will talk about meshing complex geometries and also mesh design, and how to use the tools of mesh module to design a mesh appropriate for a problem. And finally, I will talk about how to define mesh transition zone to decrease the number of elements and have a more efficient simulation. Here you can see the mesh transition zone. In this chapter, I have solved more than 20 examples. Some of them are in the 3D space and some of them are in the 2D space. Chapter 6 is about modeling tensile test. In this chapter, I have conducted 2D and 3D simulations on the tensile test, and finally I have compared their force displacement curves. I have created the specimens according to the ASTM standard. This standard is one of the widely used standards to do the tensile test. Chapter 7 is about modeling of a plate with stiffeners under blast load. In this chapter, I have done the simulations for a plate without a stiffener, and then I have added 3 stiffeners to the plate, and finally I have added 6 stiffeners to the plate. And finally I have compared the results. Also, I have done the simulations with solid elements, and I have compared the results of using solid and shell elements together. Chapter 8 is about contact theory. In this chapter, I have talked about contact theory from a practical point of view, and I have talked about contact pair method, general contact method, and surface-to-surface contact method. Also, I have talked about contact interaction property formulations, and also I have talked about contact outputs. In this simulation, you can see the sticking and slipping regions, and also the regions without contact. Chapter 9 is about solving quasi-static problems using dynamic steps. In this chapter, I have solved 2 main examples. The first one is the rolling simulation, and I have done the simulation in 2D and 3D spaces, and finally I have compared them. And the second example is about bolted connections, and I have simulated a lap joint including 2 bolts. In both the examples, I have done the simulations using static general, dynamic implicit, and dynamic explicit steps, and I have compared the results to show the efficiency and accuracy of using dynamic steps instead of a static general step. Here you can see one of the reference papers for chapter 9. It's about scratch behavior of multi-layer polymeric coating systems. In this paper, they have used the loading rate technique to do the simulation efficiently, and also I have explained it in this chapter. Here you can see 2 other reference papers of this chapter. The second one is the guidelines for modeling the preloaded bolts in the structural connection using finite element methods. And the third one is guidelines for modeling 3-dimensional structural connection models using finite element methods. I have used the guidelines presented in these 2 papers in the modeling and simulation of the lap joint, including 2 bolts. Chapter 10 is about buckling and post-buckling simulation. In this chapter, I have used both the beam and solid elements to do buckling simulation, and then I have used solid elements to do post-buckling simulation. Here you can see the post-buckling simulation, and at the center of the beam we have the deformation due to the buckling. In this chapter, I have used 3 steps. Buckle step to do the buckling analysis, and dynamic explicit and static Rix steps to do the post-buckling analysis. And here you can see the comparison of the dynamic explicit and static risk results. And to do the post-buckling simulations, I have defined imperfections according to the buckling modes. Here you can see the reference paper of this chapter. It's about experimental study on the compression mechanical behavior of steel pipes with mechanically induced pitting corrosion. As you know, studying the mechanical behavior of corroded pipes is one of the hot topics for both the mechanical and structure engineers. And this paper is one of the widely used ones in this field. Chapter 11 is about damage analysis. In this chapter, first I have talked about damage theories and continuum damage mechanics, and then I have solved two examples. The first one is about tensile test, and I have done the simulations in 2D and 3D spaces, and finally I have compared them. Also, I have studied a sensitivity analysis on the damage parameters and their effects on the final results and the force displacement curve and the damage pattern. In the second example of this chapter, I have simulated the high velocity impact of a steel projectile to the aluminium plate. And I have conducted the simulations for both the rigid projectile and deformable projectile cases with and without considering symmetry boundary conditions. And here you can see one of the reference papers for this chapter. It's about experimental and numerical studies on the ballistic impact response of titanium sandwich panels with different face sheets thickness ratios. And here you can see the second reference paper of this chapter. It's about calibration of ductile fracture properties of a cast aluminum alloy. And this is the third reference paper for this chapter. It's about on the application of stress triaxiality formula for plane strain fracture testing. Chapter 12 is about how to use Abaqus documentation. Here you can see the first page of the HTML version of Abaqus 6.14. In this chapter, I have talked about all of these sections of the Abaqus documentation, and also I have talked about how to use the examples and also how to read and use the explanations in the Abaqus Analysis User's Guide and Abaqus CAE User's Guide. Chapter 13 is about writing codes in Abaqus. Generally, we have three procedures to write codes in Abaqus. They are writing subroutines, writing scripts and macros, and finally writing keywords. About writing subroutines, I have written the deflux subroutine in chapter 14 to define moving heat source. And about writing scripts and macros, I have explained and ran the scripts in chapter 13 for creating a single model and how to implement for loops to define several models automatically one after another. And about writing keywords, I have conducted post-buckling analysis in chapter 10 by introducing imperfections based on buckling modes, and also I have defined infinite elements to do wave propagation simulation in chapter 13, and finally I have defined element removal of damaged concrete for the CTP model in chapter 16. In chapter 14, I have talked about heat transfer and thermomechanical analysis. First of all, I have talked about heat transfer theories, and then I have conducted a simulation using semi-coupled technique. And here you can see the thermal solution and you can see the moving heat source. It is defined using deflux subroutine, and here you can see the mechanical solution. First we do the thermal solution and then we use the temperature field to do the thermomechanical analysis, and we use the calculated temperature field to calculate the thermal strains. Chapter 15 is about linear and nonlinear vibration analysis. In this chapter, I have analyzed the vibration of a cantilever beam. I have done 3 different procedures: linear frequency analysis, nonlinear frequency analysis, and finally linear dynamic analysis. In the first procedure, I have modeled the cantilever beam as a 2D beam, 2D shell, 3D beam, and 3D solid, and I have compared the calculated frequencies with the analytical results. In the second procedure, I have modeled the problem as a 2D beam and investigated the effect of the pretension on the calculated frequencies. And finally, for the linear dynamic analysis, I have modeled the problem as a 2D beam and simulated the dynamic response using the modal dynamics and dynamic explicit steps. And finally, I have compared the results. Here you can see the analytical calculation of the first 4 frequencies for the transverse vibration of the cantilever beam. And also here, you can see the results of the 2D beam model, and as you can see, the results are similar to each other. So it means that our simulations are correct. Chapter 16 is about concrete analysis. In this chapter, first I have talked about the CDP model and how to calibrate the CDP model for every kind of concrete, and I have defined its mechanical behavior using Excel files, and then I have solved 2 examples. The first example is the compression test simulation with element removal, and I have done this simulation using Abaqus 2022. Because only in the new versions of Abaqus we can define element removal for the CDP model. I think from version 2018 or 2019 this capability is added to the Abaqus, and as I had Abaqus 2022, I have done this simulation using this version. Also, all of the other simulations are conducted using Abaqus 6.14. For the other simulations, I have used this version because most of the users of Abaqus use newer versions, so they can use the files provided in this package. The second example is about 4-point bending test of reinforced concrete with and without element deletion. Here you can see the tensile damage contour, and here you can see the propagation of the cracks, and they start from the bottom of the beam because at the bottom of the beam we have tension. And also in the simulation you can see the unsymmetric damage propagation of the concrete, and also it propagates in an oblique pattern. Now I'm gonna talk about other related Abaqus packages. Instead of the comprehensive Abaqus package, we also provide some other packages, including Abaqus Essentials package, Abaqus package for mechanical engineers, Abaqus package for structure engineers, and finally customized Abaqus package. Abaqus Essential package includes chapters 1 through 9, and Abaqus package for mechanical engineers includes chapters 1 through 15. Abaqus package for structure engineers include chapters 1 through 16 except chapter 15 and example 1 of chapter 9. And customized Abaqus packages is for people who wants to have a package according to their own needs. You can tell us your field of interest or your project or thesis topic. Then we suggest which set of chapters suits your needs. the total cost of the customized package is less than the total cost of the chapters included. Here, I want to give you more explanations about the customized packages according to your needs. If your project is about metal forming, you can purchase the Abaqus Essentials package. And if it is about additive manufacturing, you can purchase Abaqus Essentials package and Chapter 13 and Chapter 14. If your project is about seismic analysis of a concrete dam, you can buy Abaqus Essentials package and Chapter 16. Also, if it is about high velocity impact on a reinforced concrete block, you can purchase Abaqus Essentials package and Chapter 11 and Chapter 16. Or if it is about buckling and post-buckling analysis of corroded pipes, you can purchase Abaqus Essentials package and Chapter 10. I want to repeat that these projects are only examples. And if you tell us about your project, I will suggest you the packages and chapters suits your needs. Now I'm gonna talk about how to purchase packages or individual chapters. Each of the mentioned packages and individual chapters includes CAE JNL and IMP files, step-by-step tutorials with detailed explanations and investigation of the results, and finally slides and reference papers and standards. Packages, specifications, and payment details are provided in the video description. Also, you can pay the cost of the mentioned packages in 2, 3, or 4 installments according to your budget or income. Now, I want to talk about gifts for buyers. These gifts are provided for the buyers. A permanent 30% discount to purchase every premium package or tutorial on the FEMEX YouTube channel. Also, a 30% discount on online tutoring and consultancy services. This discount is valid for up to 4 months. About the updates, in the future, they will be provided for free for everybody who purchases each chapter or each package. The cost of each chapter or package will increase after each update for new buyers. But those who purchase the package would have endless access to all the upcoming updates. This will make the content up to date for new needs and new problems which must be solved via FE simulation. You can contact us using Telegram or WhatsApp, or you can send email to us. We can have one-on-one tutoring on the AnyDesk WhatsApp and making special tutorials to your order, and we can conduct high-quality simulations for your thesis, exercises, and industrial projects. Also, we offer support in writing the modeling and result discussion part of your thesis, and also we have consulting services for MSc PhD positions or job interviews. And finally, we can tell you how to prepare the presentation of your simulation works. Now I want to suggest you several related videos of our YouTube channel. Thank you so much for watching this video. Have a good time. Goodbye.